So let me first introduce Ron OLSEN. And Ron is joining us from GridSME. At GridSME, a little bit of background about GridSME for those not familiar with our firm. We're here because we understand that people feel overwhelmed when facing the complexities of the power grid. Our subject matter experts deliver tailored solutions that help our clients move their projects forward, grow their business, and build a sustainable and reliable energy future. We're here to serve as your guide in your project's life cycle, from the very beginning when your projects are just an idea through to COD and ongoing operations. GridSME is here to help you solve problems faster in the areas of interconnection and engineering services, reliability and compliance, grid security, and grid technology. So at GridSME, Ron OLSEN leads our interconnection services team, where one of his primary responsibilities is to ensure our clients get their projects through the CAISO new resource implementation process on schedule. He also helps our clients find innovative ways to design, interconnect, and meter their projects within the rules of ISO tariffs, procedures, and business practice manuals. Ron joined GridSME in 2019. And before that, spent more than a decade at CAISO, where he designed and implemented and managed the ISO's new resource implementation process. And in doing so, he earned the name Mr. NRI. All right, Ron, if you're there, let me turn over the controls to you.
Hello, so thank you for joining, and I will be presenting multiple slides. Hopefully we have about 20 minutes each. And this presentation is going to cover 3 areas: maximizing your option with your interconnection agreement, metering options for AC and DC coupling, and some of the real-time telemetry and hybrid data that needs to exchange with the ISO with a co-located resource. Just a bit of tribal knowledge inside with interconnection agreements. Typically there's 3-party and 2-party agreements. The 3-party agreements are the ISO, the utility that you're connecting with inside the ISO's VA, and the ISO itself. A 2-party agreement is typically the utility you're connecting with and the interconnection customer themselves, which is typically a WDATA Rule 21. And there's 2 other ways that interconnect or become a participant. The ISO's market is a pseudo resource, which is typically a resource that's outside the physical boundary of California, but then appears to be as inside the BA to operate in the market. Dynamic resources also are an option. They are, again, outside the physical borders of California, but can also import their energy into the ISO market as well. Our next slide here is really going to open up just the different fuel types that hybrids of co-location or co-location hybrid or renewable plus storage. There is a mixed fuel type, which is typically going to be assigned to any kind of hybrid renewable that has solar and storage behind a single interconnection agreement, or a standalone battery, which will typically take the NGR model, which is called the non-generating resource model in the ISO market. Then we have solar, and standalone wind. Want to define co-location. Co-located resources doesn't necessarily mean a hybrid, but what it does mean is that the generator interconnection agreement is memorialized with 2 different fuel types, typically solar at this point, potentially wind, with another fuel type, and in this case, storage fuel types. And what it is that you'll have a single net megawatt that you cannot exceed with both fuel types. However, with those fuel types, and you have storage, you have solar ramping up in the morning, you can have more storage on, and then as your solar peaks out, your storage needs to tail back, and then again on the other shoulder hours. So a hybrid resource in the ISO market is that you're taking your generator interconnection agreement, your GIA, and using all the fuel types in it under a single CAISO market resource ID, as we call it, resource ID, and modeled as such, meaning that you don't plan on separating out your solar from your storage and combining those two together, which they call as a mixed fuel type inside of the ISO's market systems. Then defining solar and storage resources, meaning that you want to keep them separate. Each fuel type will have its own resource ID in the ISO market underneath a single GIA, and then those two working together cannot exceed the GIA's POI net megawatts at any time during the operations. As well as that, you may want to keep the solar separate so that you do benefit as being a EIR or an eligible intermittent resource under the California rules, or a VER, or variable energy resource under the FERC rules. We're going to be diving into more of the co-location hybrid resource and just going over that as it pertains to metering and metering of a hybrid resource. So co-located GIA could be solar or wind with a storage fuel type. And we're going to now go through hybrid, which is a single resource ID underneath the GIA, and the resource cannot exceed the POI. So we're going to go through that at this time. So three-party generator interconnection agreement facility configurations can be wind or solar. We have already addressed that. Battery storage, and we have combined battery and storage. We have a hybrid and unique resource ID for each fuel type. However, we're going to be going into the next slide of co-located AC coupled generator and storage. So in this slide here, we are talking mostly about AC coupled versus DC coupled. AC coupled meaning that all of the storage is under its own set of inverters or an inverter by itself, and the solar and or wind is completely electrically separated. At this point, you can, with ISO metering, you can put on multiple meters across these different feeders of strings of batteries or of your renewable, and then the ISO can collect all those meters and aggregate them together, giving you a metering option of being able to take. Let's just take, for example, you have 2 PPAs and 1 for the storage, so you have 3 PPAs, 1 for the storage, 2 for the solar, and you can take the metering itself and aggregate meters across all your different feeders. And if you had 4 meters, 2 of them were for PPA number 1, 2 of them were for PPA number 2, and then you had your other off-taker for your storage. Those can be all aggregated inside the ISO. Of course, that metering there would need to be on the same voltage buses, usually your 34.5 bus if you're grid connected. Advantages to this would be that the ISO would be pulling the meters directly and submitting that data directly into settlements, as well as you can request the ISO to report those intervals of energy into the REGIA system for your credits. So this here is a simplified single line drawing, trying to depict what I was mentioning earlier, with the storage being on the left, the solar being on the right. You essentially have 3 PPAs potentially here, or 1, but 3 PPAs. One PPA for the storage would get the meter number 2. Another ISO meter for M3 would go to another PPA potentially, and then meter number 4 would go to another. This all here is a legitimate metering setup and design for keeping your solar plus storage separate on the AC side, and also keeping your credits available for potentially ITS, where you could have solar generation from the right, storing into the battery storage on the left. Our AC coupled is considered a CAISO metered entity. I'm going to recap here is that the non-generating resource type, which is typically for storage resources, is going to be an NGR model. And using the NGR model, the ISO will report the metering load channel to settlements at this particular time. So there is some debate of how that's possible in order not to be double billed. Also, the low side metering can be aggregated into a single, resource ID or to multiple resource IDs. The other avenue here is to electrically design your inverter system to manage any future PPA obligations that you are trying to meet or that you are trying to design into a market system, where what we have been seeing on the engineering side is many designs just have a single meter on the high side of a GSU or step-up transformer to the interconnection. And then once they are ready to construct, they're in parallel, they're trying to manage their PPAs, and what they're finding is that their electrical design didn't take into account separating the PPAs or separating how you're going to market this unit on the ISO market systems. And so in order to manage that type of aspect is that the inverters are the separation for each PPA. So in other words, is that an inverter can't be split in half with ISO metering, one to one resource ID and one to the other. And usually each PPA is a representation of one resource ID. With co-located DC coupled, it's still very possible to keep the resources fuel type separate. This is a design where if you're trying to add storage to a solar resource after your GIA has been completed and you want to go through an MMA, but you don't want to necessarily do a lot of engineering redesign in the MMA process, and you want to essentially change out the inverter to do, to go in both directions, to charge and to discharge through the inverter. The DC coupling affords that avenue to allow you greater flexibility with the current electric design of the solar feeders. And in this case, too, the DC coupling, what we're going to go through is DC coupling, how we're going to keep it separate, the two fuel types separate from the solar versus the storage. And how we do that is typically after the step-up pad mount transformer that goes from 600 volt typically to 34.5 kV, we have an AC meter. We have DC metering down below the inverter on each fuel type, which gives us a percentage of output. And then at this point, we can use a different metering plan, which I'm going to go over here in a couple more slides. As well, with a DC coupled resource with storage, that could be your ultimate hybrid as well, where your storage is being the state of charge of the storage is being done by the DC coupled on itself from the solar, and then after your shoulder hours hit or evenings, you can discharge that fuel type into the ISO market. And then after, the other advantages of DC coupled by keeping them separated is that later on in 5 years, you could aggregate those two resource IDs to a single resource ID, and then use it as a market unit, a single market resource ID. This would be just a high-level DC coupled storage plus solar, where we have revenue metering and on your solar only, and you also have revenue metering on your solar plus storage. Where here you could potentially have two PPAs where you're either a hybrid on the right and a solar on the left, or you could have multiple resource IDs using a particular plan, which is called the settlement quality metering plan that we will be discussing here pretty quickly. And that takes us into this right here. So with DC coupling and CAISO settlements for settlement quality meter data, there is a plan that you can put into place where you can logically separate these two fuel types into each of its resource IDs itself, where you can still market the DC storage and the DC solar as if it was two separate fuel types, even though they're electrically connected. The settlement quality meter data is also submitted directly into the settlement system, which is called the market result interface system, and it bypasses the ISO's meter quality data system itself. As well as using this plan, your AC metering must also adhere to the ISO's accuracy standards. The advantages are allowing you to split inverters across many different resource IDs, where on AC metering you can't do that. There's no yearly ISO calibration. You can also use logic to determine your round trip losses and so on. And as this results is that, you know, the CAISO tariff supports SQMD, which then translates that the FERC has approved that way of submitting 5-minute intervals into the settlement system. Just to wrap up, the single resource ID for a mixed fuel type, whether AC or DC, you have one resource ID, which means only metering on the high side of the transformer. However, if you wanted to take that hybrid resource, either AC or DC coupled, and you wanted to serve multiple PPAs, then all of the metering needs to move to the low side. And then again, if it's AC coupled or AC hybrid, the PPAs and the metering need to be on the inverter boundaries, where you cannot share inverters between PPAs. And then, and again, the hybrids will also be polled by the ISO if you wanted to, or we can do an SQMD plan by slicing up inverters. 1 second here. Again, multiple hybrid resource IDs on a single POI, as we call it, whether AC or DC coupled. Again, the metering need to be on the low side of the step-up transformer when using AC coupling. All the different AC meters could also be aggregated across multiple resource IDs, or if you're DC coupled, we'd be using a CAISO SQMD plan, and we would use high side and low side metering plus DC metering and logically separate all of the generation for your PPAs or your resources. So our picture here is you have a couple different choices when you go from hybrid versus single resource IDs for each fuel type. Bear in mind again, if you have multiple PPAs for the solar and multiple PPAs for the storage, there's a way to divide those, if you will, through either metering or SQMD plan. Hybrids, it's pretty much a slam dunk how it could be done with metering. especially if the inverters are on the AC bound metering scheme itself. You can do a hybrid resource with SQMD by being able to slice up inverters between PPAs or resource IDs. I'm using PPA and resource IDs synonymously so that we can move back and forth between those two. The resource ID in the ISO market is typically it's the ticker like in the stock market. So it's very unique to just that resource field type. Our next set of slides are really going to talk about real-time telemetry. A lot of our interconnection customers send us a lot of questions about telemetry, so I decided to go ahead and cover that slightly. The ISO requires direct telemetry to all ISO participants. And if you remember one of the first few slides, you had two-party, three-party, pseudo-tie, and dynamic. The only resource that doesn't need direct telemetry is the dynamic resource that's outside the ISO's VA. The dynamic resource will be used in ICCP. But all the majority of resources in the ISO's market uses direct telemetry. And the direct telemetry requirements are DMP3 protocol, and there is a TLS 1.2 encryption that is wrapped around that DMP3 protocol. There's also network devices out there that can do the encryption between the ISO and the interconnection customer's firewall, and then on the interconnection customer side of the firewall, you can be in the clear with the DMP protocol and create your own direct telemetry device behind your load balancer, for example. There's plenty of SCADA systems, RTUs, different types of devices that can talk DMP3. As well, this is also a lot of different questions we get from interconnection customers is about the state of charge and reg up and reg down. So the state of charge is managed if you're an ISO control, if you're on the ISO control grid, whether you're DC coupled or AC coupled, or whether you're charging from the grid, all of that charging must be submitted into the market as if it came from the grid. So the ISO will be managing the state of charge in those storage devices based upon the scheduling coordinator's bid structure and so on, as well as the way the ISO charges or discharges your storage device is through the real-time direct telemetry via what's called automatic generation control set points, or AGC set points, which is your AES market reg up, reg down. The other telemetry that originates from the ISO to consider is either through a user interface or a application interface, and that is the day-ahead awards and the real-time awards. And why I'm bringing this up is that in some systems, our storage interconnection customers are learning that with solar, they didn't have to worry about necessarily taking AGC in and out of remote control with the ISO. But with storage being added to these co-located resources, you will have potentially awards in the real-time market where you need to put your resource into AGC remote so that you don't miss your AES requirements. And that's going to conclude my slides. Thank you very much for being with us.
Hey, Ron, thank you. Let me actually, I got a couple questions for you before we go to Sarah and talk about tax. First question for you. Besides data management advantages, are there any financial advantages or market participation of having different meters for different assets?
Well, if your asset needs to be on the boundary of the inverters, the meter is a definite way to memorialize every 5-minute interval going into the settlement system, so it can be traced from hitting the grid all the way through your system. So there is an advantage for metering, hard meters, not virtual meters or SQMD meters. Yes, it really is a case-by-case basis too.
Yeah. So, and whether you're using hard meters or virtual meters via SQMD, either way, I guess it sounds like a couple of advantages would be the metering allows you to set up multiple resource IDs, which allows you to segregate your solar, keep it in EIR, VER status, right? And
Right.
accounted for separately, which would then also allow you to set the storage up as its own resource as well.
That is right.
Okay. Yeah. And then you can also, I mean, the more metering you can do, whether virtually or hard, the more ways you can slice off your project under different PPAs, right? Because am I understanding it right that each PPA needs to be associated with a resource ID, right? You couldn't have one resource ID that had multiple PPAs.
No, usually 95% of the time each PPA is requiring their own resource ID. But yes, you could slice up if it's AC coupled, you can slice it up based upon whole inverters. If it's DC coupled and you need to slice up inverters between PPAs, you can use the SQMD plan, but in both cases, you will still have settlement quality data sitting in the settlement system to report, your ITS credits if you needed to.
Okay.
Both systems are completely legitimate and they're approved by the ISO. Yeah.
Okay, very good. And one more question here for you before I let you go. Have you used any HIL testing technology for storage monitoring control testing?
No, I have not personally.
Okay. Thank you, Ron.